Hey, let's see if we can finish up with 7 through 9 from the back of the Chapter 2 review worksheet. So, number 7, this is going back to Chapter 2.1, where we learn about the general limit definition of a derivative. But this is not asking it in a straightforward way. This is more of a concept question. So, this problem is in the form of a limit definition of a derivative, and what this is being asking you to find is to see if you can recognize that what this pattern or what this notation represents. So if we go back to the limit definition of a derivative, once we plug the function into this notation and we evaluate, all this represents the derivative function. Okay. Now we've learned about all the shortcut methods with power rule and all the more efficient ways to find the derivative. But what they're testing on is, do you understand that this also represents the derivative function? Although it's a lot messier, it represents the same thing. Okay. But if you notice that all the x's are not showing up in this notation. All the x's have been replaced by a specific x value, by a specific constant. So this is not only asking you to find the derivative of a specific function. This is asking you to find to evaluate the derivative of that function at this given point, and that given point is at -1. So the question also is, how did this get to this point? How can we figure out what this function is referring to? Because when we went through limit definition of a derivative, we always started off with a function, and that function we would plug it into this notation, and then we would try and clean this up by finding a way to factor out the h so that we can cancel that out, so that we can get this down to a specific function or specific value. But when we first plug it in, it's going to be a little messy with all the parentheses and all the h's that show up. So how do we backtrack? How do we look at this and figure out where this all started from? So we can look at the f of x plus h portion. That's going to be the portion that we can get the most clue from. So I'm going to cover this up. This -1 represents f of x at 1, or f of x at -1. Okay. So if we look at this, we can kind of figure out where this is coming from, right? Because we replaced all the x's with x plus h, and then what they did was they replaced the x with -1. But we can just think of this whole parentheses as a variable, as the x. Okay. So if we think of this as the x, and if we think of this as the x, then our function is just what? 2x cubed minus 3x. So if this is our function, then we kind of know where this is all coming from. Okay, so this is in reference to this function here, 2x cubed minus 3x. But all the x's have been replaced, so this is asking you to find the derivative for this function and then evaluate it at this x value, -1. So this is asking us to find f prime of -1 using, for this function, 2x cubed minus 3x. So if we're trying to find f prime of -1 for f of x, then we can simply go through a more efficient rule with the power rule. So we don't need this anymore. We already know that this is referring to this function. This is asking us to find f prime of -1. So now we can just resort to the more efficient way of finding the derivative, and then just plugging in the -1, or evaluating the derivative, finding the exact slope at this point on the curve. So to find f prime of -1, we first need to go through finding f prime. So f prime of x is simply going to be 6x squared minus 3x. And then once we find f prime of x, then we can find f prime of -1. So plug -1 in for x. we're going to get 6 times negative 1 squared, which is 6 minus 3, which is 3. So f prime of negative 1 is 3. So this whole thing is asking you to find what is the slope of the tangent line to the curve for 2x cubed minus 3x at negative 1. So this is what all this represents. We need to be able to look at this problem and know that this is in the form of limit definition, and this is essentially asking us to find f prime of x, or f prime of negative 1. Okay, number 8 is in a similar way, but using the alternate definition. So again, the alternate definition here is asking us to find the derivative at a point. But here, they already gave you the function, so we need to figure out what x value it's asking us to evaluate, or the derivative. It says x approaching negative 1, so negative 1 is going to be the x value that we're trying to evaluate the derivative for. So we need to find f prime of negative 1. This is what this notation is asking us to do. So we need to first find f prime of x. So go through power rule, we get 4x cubed minus 4. Plug in negative 1 in for x. We're going to get negative 4 minus 4, which is negative 8. All right, number 9. Find the points at which the graph of the equation has a vertical or horizontal tangent line. So to find vertical and horizontal tangent line, we first need to find the derivative equation. In this case, if we want to find the derivative equation, notice that this is not an explicit function. It's not solved as y equals and all the x's on the right side. This is y's and x's mixed in together. So we have to go through implicit differentiation. So implicit differentiation, we find the derivative of each term like we normally would, but if we come across a term that has a y in it, we need to make sure that we find that after we find this derivative, we're going to have to attach a dy over dx. Okay, so now let's look at these terms. All these terms are, we can find the derivative using power rule. No need for product or chain rule or quotient rule. All these are individual terms separated by plus or minus. So 4x squared becomes 8x. Y squared, okay, so if we find the derivative for y squared, we have to attach dy dx. So y squared becomes 2y dy dx. 8x becomes negative 8. When we find the derivative for 4y, we have to attach a dy dx because there's a y term in it. So 4y becomes 4 dy dx. 4 is a constant, goes to 0, and then 0 will stay 0. Okay. So we want to find the derivative equation, so we want to find a way to group the terms with dy dx on the same side. Everything else without dy dx will move to the other side. Once we do that, and the left side has dy dx, we can factor the dy dx out, divide both sides by 2y plus 4, and then once we do that, we can factor out the 2 from both expressions. Cancel out the 2's, we're left with 4 minus 4x over y plus 2. So here's our derivative equation. So first, let's find the horizontal tangent line. So horizontal tangent line is where the graph has a slope of 0. So to do that, we set the numerator of our derivative equal to 0. So my numerator of the derivative function is 4 minus 4x. Set that equal to 0. We solve for x. We get x equals 1. But they're asking for the points, so they're asking for the ordered pairs. So we plug 1 back into the original equation. Okay, we're trying to find the location, the physical location of that ordered pair. Plug 1 into the original equation and work our way down. We get y squared plus 4y equals 0. So there's going to be two y values that share the same x value. So y is equal to 0, y is equal to negative 4. So there's going to be two ordered pairs where slope, there's going to be horizontal tangent line at x equals 1. So we have 1, 0 and 1, negative 4. Okay, this may seem strange to have two ordered pairs on the same graph that share the same x value, but it's because we have an equation that's not a function. So it's not necessarily going to pass the vertical line test, and we see that here. Okay, part B, the next part, find a vertical tangent line. So to find a vertical tangent line, that's asking us to see where does the slope not exist. So the slope is not going to exist where the where the denominator of the derivative is equal to 0. So we simply set the derivative's denominator, which is y plus 2, set that equal to 0. Solve for y, we get y equals -2, and we want to find the physical location for that point, so we plug that y value back into the original equation so we can find the ordered pair, plug -2 in for all the y values. We're left in terms of x, and combine like terms, we get 4x squared minus 8x equals 0. Factor out the 4x, so we get x equals 0 and x equals 2. So there's going to be two x values that share the same y value. So that'll be 0, -2, and 2, -2.